Good morning to all. Today we are going to see about backpropagation algorithm. In the backpropagation algorithm, there are two passes are available. One is forward pass, another one is backward pass. So first you'll see what is happening within single neuron and how it calculates the output to next level neuron, how the error is calculated at the output layer, and based on that how the backward side weights are updated and how the inputs are forwarded in the next level of pass. First I'll explain about single neuron. So here in this example, whatever circle given here is considered as a single neuron except the input layer. All the hidden layers and output layer neurons receives more number of inputs. So each number of inputs are represented as a xi. For example, here it can be represented as x1, x2 up to xn. Sometime bias also may be given. If the bias is given means it can be represented as a b. So here within the neuron there are two works happenings. One is considered as G, another one is represented as F. G is nothing but all the inputs, that means all the X are multiplied with the corresponding Y. If bias is given means it will be added at the last. So the summated weight is considered as a G. Then after that, activation function is given as F. Here the activation function gets this G and output is calculated. The output can be represented as a Y cap. Usually we will mention Y as a output. Why we are mentioning here means Y cap means what output we received. So this is happening in each and every circle. There are two functions happening. One is summation of input with corresponding weight plus bias. Like this it is happening. So here there will be no change in the input and there is no change in the final target. So what we are going to change means when we are forwarding, the input will be forwarded to the output layer. We will calculate the output. Then the difference between this target and our output will be calculated. That is called loss. There are so many loss functions are available. For example, here mean square error and cross entropy error is given. So simply if you are calculating mean, this is called absolute error. There are so many loss functions are available. So any one of the loss can be calculated. Now there is a difference between error and loss. Error means simple difference between one target and one output is called error. If you are having multiple input output combination, average can be considered as a loss. So based on this loss, we are going to forward the loss to the backward direction. So in the forward direction, we calculated output. In the backward direction, from the error, we are going to propagate to backward direction. So automatically what will happen? So every time in the backward direction, the weights will be updated. So W is the weight. So the new weight can be calculated based on this old weight, this learning rate, sometimes it can be called as theta, based on this gradient. So gradient is nothing but the loss based on this weight. After this weight updation, so we have to update the weight. So here each and every edge has some weight. So weight will be updated. So after updation, again the original input is forwarded with updated weight. So this is called W new. Here we are having 3 neurons in the input layer, 3 neurons in the hidden layer, 3 neurons in the output layer. So all the weights will be updated. So after based on the update weight, again the Y will be calculated, Y cap will be calculated. Then again this target and output will be verified. This will happen again and again until there are two conditions. Either there will be no loss. If there is no loss means we can stop this forward pass and backward pass. Otherwise, maximum number of iterations are reached. In this condition also, we can stop this algorithm. So these are the two ways to stop this algorithm. Either there is no loss, otherwise maximum number of iterations are reached. Next, we'll see the simple example. Here I have taken one neural network which is having two inputs x1 and x2. x1 value is 0.05, x2 value is 0.10, and x1 is connected with the hidden layer 1 and hidden layer 2 with the weightage of 0.15 and 0.2. In the same way, x2 is connected with the hidden layer with the weight of 0.2 and 0.3. Both hidden and layer 1 and 2 having the bias 0.35. Bias is always optional. If the bias is given means we have to consider. If it is not given means we can omit in the summation. And in the same way, hidden neuron 1 is connected to output neuron with the weightage of 0.4. Hidden neuron 2 is connected with the output neuron with the weightage of 0.45. The bias for the output neuron is 0.6. Here the target is given as 0.01. It is fixed, and the learning rate is 0.5. It is also fixed. Activation is sigmoid. So where activation function can be applied means in all the hidden layers and the output layer, activation function can be applied. Here what are fixed? Input is fixed 0.05 for x1, 0.10 for x2. These two values are fixed. This won't change. And the target, learning rate and activation function, these are also fixed. So here we have to pass this input x1 and x2 to the output layer. At the time, if any error happens means we have to backward that error, so that we have to update all the weights and also bias values. So this is the concept of backpropagation algorithm. So here we are going to see just one iteration, how the error and bias values are calculated and how it is affecting the weight. That is why we are going to apply this algorithm. The first step is we are going to use the forward propagation. So in the, as I said, in the input neuron, there is no change in the input. So we have to calculate in the output neuron, sorry, hidden neuron. In the hidden neuron, we are having two inputs, x1 and x2. Here x1 value is 0.05, x2 value is 0.10, and the weightage for x1 is 0.15, weightage for x2 is 0.2. So we have to apply summation of xi corresponding with the weight I plus bias. So 0.05 is multiplied with corresponding weight 0.15 plus x2 value, that is 0.10, is multiplied with corresponding weight 0.20 and bias is added. Bias value is 0.35. So we will get the input 0.3775. So this is the input for the hidden layer. So this is the value for the hidden layer 1. Then after getting, we have to apply the activation function. Here sigmoid is the activation function. So sigmoid of this 0.37555. So this value is 0.59327. So this we can calculate by just calculator. Otherwise, we can apply the standard equation of sigmoid function. In the same way, we have to apply for the hidden layer 2. So for the hidden layer 2, how many inputs are there? Again, x1 and x2 with different weightage. So we have to apply x1 with corresponding weightage, x2 with corresponding weightage plus bias value. So we are getting the input for hidden layer 2 as 0.3925. We have to apply the sigmoid function. So we will get this answer. So now what value we got? We got this h1 value and the h2 value we got. Again we have to forward this h1 with the weightage of 0.4, h2 with the weightage of 0.45 to the output layer. So after getting summation, again we have to apply the sigma to get the output. Okay. So what is the output layer input? That is hidden layer value 1 with the weightage of 0.40 and the hidden layer 2 value with the weightage of 0.45. So that value we have passed here plus bias value. Bias value for the output layer is 0.6. So that we have added. So we are getting the input as the answer of this equation 1.10591. Output is calculated by just sigmoid of this input. So we are getting this value 0.075137. Now we have to calculate the error. In the previous slide, our output is 0.3 75137. So our target is given in the question itself. So I have applied mean square error. The formula is 1 by 2 target minus output the whole square. Target is 0.01. It's given in the question itself. Our calculated output, that is y cap. So what is y cap? 0.75137. This is the value we have calculated now. So we have to apply in this equation. So after applying, we are getting this answer. So this is the mean square error which was calculated at the output neuron. So based on this, now we have to calculate the loss function, and the loss function should be propagated to the backward so that all the weights can be applied. So now our forward pass is over after calculating the error. Then we have to do the backward pass. So first step, we have to calculate the del, that means loss value at the output layer. So this is the standard formula. Loss at the output layer is equal to target minus actual output. This is nothing but our y cap. Target minus output multiplied by output into 1 minus output. So we know our target is 0.01. So this is the value what we received y cap, and 1 minus this y cap. So like this we have applied. So we received answer of this equation as minus 0.13850. So this is the loss at the output layer or error at the output layer. So based on this, we have to update. So this is the formula to update the weights in the output layer to hidden layer. From the output to hidden layer, we are having three weights: W5, W6, and bias also we have to update. So based on this, we have to update. So already we know that for the hidden layer 1 to output layer, the old weight is 0.40. And this 0.5 is a common learning rate given in the question itself. And this del naught we have calculated in the previous one. So this del naught is the same value, 0.1385. And this H is nothing but the hidden layer output. So for the hidden layer 1, this is the output. For the hidden layer 2, this is the output. For bias, 0.60. So like that, as per the formula, we have to apply. So now, after applying these values, we received revised weight W5, revised weight W6, revised bias B0. After updating hidden layer, from the hidden layer to input layer, again we are having set of weights and bias. That already we calculated the del value, that is nothing but error value or loss value in the output layer. In the same way for the hidden layer, this is the formula. So H1 is the hidden layer output. 1 minus H1 is the 1 minus hidden layer output. So del naught is the error in the output layer. W5 is the updated weight. So by using this formula, we have to calculate. So now we got the error value at the hidden layer. So this will be useful for updating in the previous layer. In the same way, we have to calculate for del H2, error at the H2. That means output of the hidden layer 2, then 1 minus hidden layer output, and del naught, that means output layer error multiplied by updated weight. So we are getting the values for the hidden layer neurons that was calculated in the previously. The same value we have to update here. So after updating, we will get the updation in the weight between neuron 1 to hidden layer 1 and input neuron x2 to hidden layer 1. In the same way, input x1 to hidden layer 2 and the input x2 to hidden layer 2. In the same way, we have to update the bias also. So after updating, we are getting the weights. 0.15 is changed to 0.14697 and x2 to h1 old weight was 0.20, it was updated to 0.19933. Then old weight from x1 to hidden layer 2 is 0.25. After this, it was updated to 0.24 963. X2 to H2, old weight is 0.3. It is updated to 0.29925. In the same way, bias also updated. In earlier, the bias was 0.35 and 0.35. So after updating the bias, the new bias was 0.34332. And for hidden layer 2, the bias was 0.34250. Now in this slide, the original problem and the updated weights are given. In the original problem, from the x1 to h1, from the x2 to h1, the weights were 0.15 and zero point 0.2. But after updation, the revised value what we calculated in the previous pages, that is updated. In the same way, all the weights and all the bias are updated. And one more thing, consider always there will be no change in the input x1 and x2 and the target in the learning rate and all. But what will be changed? The updated weights and the updated bias will be done. So based on this, again the x1 and x2 will be applied, and the hidden layer calculation is same, and output calculation is same only, and then again new output will be reached. So again we have to compare the new output, that is y cap, with the target 0.01. If there is any change in the error, based on that again the back propagation will happen. So this will be happen again and again until the either of the condition can be reached. Sometimes the error can be less, it is tolerable. Otherwise, error can be 0. Otherwise, maximum number of iteration is reached. In this case, we can stop. Here in our example, we took only one iteration. After one iteration, this many changes has done. So if you want to wish, we can do more number of iteration. Otherwise, we can do until there is no error. Thank you.